So this section contains two matrix match the column types question, and the matching given in column 1 may have more than one matches in the options given in column 2. So let's start with question number 36. Match the properties of oxides of nitrogen P1 to P5 produced in reactions of column 1 to that mentioned in the column 2. So the examiner is interested in knowing about the reaction of HNO3. So he has given us three distinct weight by weight percentages. So there is a 6% weight by weight, there is a 20% weight by weight, and then there is a 70% weight by weight. So the 6% weight by weight can be taken as very dilute. The 20% weight by weight can be taken as dilute, and the 70% weight by weight is the concentrated nitric acid. So let us look at reaction A. Zinc plus HNO3. So we know that zinc, when it is reacted with very dilute nitric acid, it forms NH4NO3. So this is our compound R. Now when this compound is heated, we get N2O, okay, which is the nitrogen oxide formed in the first reaction, which is the product P1. If you look at the second option now, Fe plus HNO3, which is dilute. So Fe plus dilute HNO3, it also gives us N2O. So the P1 and P2 are both N2O. If you look at the third reaction now, lead plus concentrated nitric acid, we know that lead on reaction with concentrated nitric acid, it liberates NO2. So the gas which is formed in the third reaction is NO2. We are only bothered with the nitrogen oxides, as the examiner is only interested in that. So NO2 is the gas P3, and when it is allowed to cool, we know that it will undergo dimerization to give us N2O4. So the gas P4 is N2O4. Let us look at the reaction given in option D, Cu plus HNO3, which is dilute. So copper on reaction with dilute HNO3, it releases NO. Okay. So now let's try and match the properties of the gases. So if we talk about N2O, students, N2O is a colorless gas. N2O is a neutral oxide as well. So the gas produced in reaction 1 is N2O. So it will be matched with PS, and the gas produced in reaction B is also N2O. So it is also going to have the same options. So the B option will be matched with P and S again. If you look at option C now, so we have P3 and P4. So P3 was NO2 and P4 was N2O4. If we talk about NO2 first, NO2 is a brown colored gas and NO2 is an acidic gas. If we talk about N2O4, the N2O4 produced is a colorless gas. So N2O4 is colorless and N2O4 will also be acidic. So the gases produced in reaction C will be matched with P, Q and T. Let us look at the D option now. The product P5 form was NO. NO is also a colorless gas and NO is also a neutral oxide. So we have the D option matched with PS as well. So this is the correct match for question number 36. Let us look at the next question. Question number 37. Match the number of geometrical forms or isomers, which is represented by the letter G, and the enantiomeric pairs. So the enantiomeric pairs have been represented by the letter E from column 2 for complexes present in column 1. So if I talk about the first complex, which is MAA3. So it is a symmetrical bidentate ligand. So we have MAA3. So students, the bidentate ligands can only span the cis position. So they have to be connected at the adjacent positions. So we know that this is optically active. So it will have a mirror image, which is non-superimposable. So we can call it plus its enantiomer. So it will have only one geometrical form. It cannot have the trans isomer. It can only have the cis isomer. As if we try and form the trans isomer, the compound will become very, very strained. So we can see that the geometrical isomers for this complex is equal to 1. Whereas it also has one enantiomeric pair. So E is equal to 1. So the complex given in option A will be matched with P and Q. Let us look at the second option now, where we have a asymmetrical bidentate ligand. So we have MAB3. So now we'll have two geometrical isomers, which will be the meridional and the facial. So we can draw them. So if you look at the meridional form first. So we can have A, B bonded like this, and A, B bonded like this, and the A and B bonded like this. So this is the meridional isomer. We can also have the facial isomer. The facial isomer can be represented as, so here we have the facial isomer as well. Okay. So these are two distinct geometrical isomers of the complex given in option B, and both of them are optically active. So we'll have an enantiomer of the first structure and an enantiomer of the second structure as well. These do not contain sigma or I, which is the plane of symmetry and the center of symmetry respectively. So we'll have G is equal to 2, and we'll also have E equal to 2. So the complex given in option B will be matched with options R and S. If we look at the third complex now, MAB2C2. So we have MAB2C2. So again, we can have different structures for this complex. Let's start by placing the C trans to C. If you look at the options in which the C is trans to C, we'll have two different complexes. So we have M and the octahedral field around it. So we can place C trans to C, and then the ligands can be accordingly adjusted. So A and B, and in one case we'll have A trans A, and then in the other case we'll have A trans B. So when we talk about A trans A, we'll have B trans B as well. And if we talk about the A trans B, we'll have A cis A and B cis B also respectively. So these are the two structures. So C trans C has two geometrical forms, and we know that the trans isomers do not have optical activity, as there will be a plane of symmetry which will contain the other four ligands. So geometrical isomers are 2 for the trans, and if you look at the cis structures, so we have C cis C. Looking at the structures, we can have three different structures for them. So we can probably fix the position of two C's. So we fix it here. C is cis to C. C is cis to C. Now if we talk about the arrangement of the other ligands, so we can have A trans to A, we can have A trans to B, and we can have B trans to B. The other ligand shall be adjusted automatically. So in this structure we have B cis B. In this structure also we have B cis to B. But in the second structure we have A trans to B, which is not seen in the first structure. So you can see that these three are all different. Obviously these will be linked together as this is a bidentate ligand. So we have three different geometrical forms for these cis structures. If we talk about the cis forms, these will all be optically active. They do not have any plane of symmetry or any center of symmetry. So we'll have three enantiomeric pairs. All the cis structures are optically active. So if we look very carefully, we can see that the complex given in option C has 5 geometrical forms, and it has 3 enantiomeric pairs. So it will be matched with option T. So C is matched with T. And if we look at the complex given in option D, we know that this is going to have only one single geometrical form, as A will be cis to each other. Bidentate ligand can only be attached in a cis manner. It cannot span the transposition, while the other 4 positions shall be occupied by the monodentate ligands B, and which are all identical. So it is going to have only one single geometrical form. So G is equal to 1. So students, the complex given in option D shall be matched with option P. So we have the correct matching for question number 37. Let us look at the next section now.